Okay, good morning. Continue the electrical machine. By the last session, we cover up to this point and talking about what's the meaning of the different reluctance, which coming from different magnetic circuit. Uh, this figure in the right hand side, you can see it's a square core, which there is a air gap by the 0.05 centimeter and the length of the core given 373, then the other side also in the same way. So as you can see by here, it is very clear that this resistance, which one is from this point, you can see all core, okay, and the other one, which is for the air gap, are two series resistance, sorry, reluctance, okay, reluctance connected. But for this configuration, we already do some, what we call it, assumption. The first one, which are not fully correct, but for initial stage, I think it's working for all of us. The electric wire, the electrical wire, this one, okay, will have this one will have no resistance. Okay, this is the first one, and then of course the mu r of this core must given. Is it given by here? Don't think so. The material also not given the name. So usually the mu r is given as a, for example, 1000 or 2000, 3000. Be careful about these values. When I talk about 3000, usually you can see in the different references by different values. But here in electrical engineering, our values is not over than 5,000, 3,000, 1,500. Okay, look like that one. Then magnetic material pass in the air gap is something look like this one. Later I will discuss the air gap and assumption of the air gap. I don't want to cover by here, but for you to know, uh, we imagine in the air gap, just look at here, okay, sorry, in air gap, all the flux from top to down or down to up is depend to the out. See, the flux is from from this way. So I should plot it such that one, okay? All flux, okay, coming as a perpendicular from down to top. So there is no flux such as this one, means at the side. We call it fringing effect. In the real application, we have these two, okay? But here in this unit, we already ignore all of the wasted flux, okay? So for the electrical circuit, we have Kirchhoff's law, okay? You are familiar what's the meaning of KVL and KCL, correct? In the magnetic circuit, also the same things. We can use the Kirchhoff's law. The KVL here is called magnetic for the magnetic circuit. Is summation of H times L. So he's HILI over a closed pass. Over a closed pass means from here to here, closed pass. Okay, over a closed pass equal to magnetomotive force equal full MMF. So for the previous circuit is HCLC. The C, this C index is for the core, means the H inside the core and the during the length in the length of the core plus uh, H gap and L gap, which is air gap, equal the full MMF. Okay, KCL on the other way, KCL, sorry, it is assumed that H and L are parallel. Okay. Uh, in the case of KCL, the magnet for the magnetic circuit phi, which is the flux, the total flux coming in at the junction, the same as something I mentioned last time in the class. Assume we have different. This is the full flux, so it will be divided into two different flux, depend to the value of depend to the value of the reluctance. So here assume we have reluctance number 2. Here assume we have reluctance number 1. Then the relationship between reluctance number 2 and 1 given, and you can calculate what is phi 1 and phi 2. Very simple, very easy. The calculation, as before that I mentioned, don't forget, we should consider the lengths as an average. So you can see for this circuit, which is exactly the same as this circuit, okay? You can see here, it calculates the lengths for the core and then for the air gap. For the core, you can see 3 centimeter plus 7 plus 3. So the average for here is 1.5, so should be 1.5. 7 is okay, no problem. For here also we have 1.5 on behalf of 3 because we are going to calculate the average. So 7 plus 1.5 plus 1.5 is 10. No, sorry, is 10. So 10 times in this way also 3, 7, and 3. Okay, just ignore it, this value for a while. And you can see the total length L for the core, it's 40 centimeter minus air gap. Value of air gap is 0 0.00.05. Okay, so the effective value here is 39.95 centimeter. And for the air gap also given. Because this value, this one, is very close to 40, later you can use the calculation and check whether the difference between 40 and 39.95, how difference is that one, okay? We can just assume that the length of the core is 40. Then, of course, we should consider the air gap. Don't forget that one. In the case of calculation of the reluctance, just look at here, reluctance is L over mu over A, correct? The reluctance of the air gap, whatever the air gap is very, very small one, you can see the value of the air gap is 0.05, okay? Compare with the length of here, which is 40 centimeter, the reluctance of the air gap or gap is much more bigger than the reluctance of core. Later in one example, we are going to show you this one, okay? Just assume the density, flux density is equal to zero point 0.5 Tesla. So let me clear this screen for a while. I'll delete this one. Okay. Uh, The flux density is zero point 0.5 Tesla. The gap permeability of the core is 4,000. So what's the meaning of that one? It means that mu r, how can I change this one? I need my pen. Oh, it's here. Okay. So the mu r for the core is given 4,000. Can you remember last time I mentioned the value mostly in this range? Okay. And the A also for both of them, because we are going to ignore any losses of the flux. The A for both of them is 12 times 10 minus 4 square meter, because here is square centimeter. So A also given. Then what is the reluctance here? can you calculate the reluctance? We know the L for core, which is 39 point something, assume it's 40 centimeter, and the L for gap is given as a, oh sorry, this one also, but it must be converted to zero point 0.4 meter, correct? And then for that one, 0.05 times 10 minus 2 meter, correct? Okay, so from this point, we know B. B is given. B is 0.5 Tesla. A also given is there. So we can remember from formula phi equal BA. So we know the full value of phi, which is 0.5 times 12. Uh, correct? Yes. The value here is 6 something Weber. Okay. Now the question again, how we can calculate the reluctance for each part can be calculated from H, then L, because L, we know L, or means using KVL, or we should use as KCL. So in the KCL, we need reluctances and phi. So phi no, L no. Whatever, you can calculate the R, means reluctance, or you can calculate the H.